We want to convert 20 degrees on a circle to radians. So we always start with this flat x-axis here, and if I were to go about 20 degrees, I'll just draw a quick random sketch. 20 degrees is not much of the circle. They also want us to convert to revolutions, and I think I'll do that first. 1 revolution would be a full way around. If I were to cut this circle into chunks of 20, think of how many 20-degree chunks I could make. We know a whole circle goes 360 degrees. If I would divide them all into slices of 20 degrees, that would make 18 slices. So what portion, that would mean there's 18 of these little pizza wedges. What portion of the circle did I revolve around? Not very much. We would say my revolutions would be 1/18th of a revolution. I'd still have 17 more of these to go to be able to complete a full circle or revolution. So there is my revolutions. Again, when you're doing revolutions, it's nice to draw it up and like think of cutting it into slices. Okay, I'm not even going to draw 18 slices, but you get the idea. Now, to convert it to radians, when we talked about what a radian is, we said that pi radian equals 180 degrees. I actually like to use this and kind of make a cross multiplication thing. So I like to say, okay, I am going 20 degrees out of 180. Now that means like I'd go half a circle. I want to know how many radians that is. So we'll call it x. How many radians am I going out of pi radians? So this is pi radians, and of course 180 degrees. That symbol stands for degrees, but we'll write that. So this is my conversion. 180 is pi for radians. 20 degrees is another amount of radians we don't know. So let's cross multiply here. I've got 20 times pi. And this isn't the only way to do it. You might have had a previous experience that helps you convert it. I just use this conversion, and it's one way that you can always go back to. So 20 times pi equals 180 times x. Well, I'm going to solve for x. I'm going to divide by 180. Do not turn these into decimals. Radian measures are very fraction friendly, and we never multiply by pi. So 20 over 180 would be 1 over 9 with a pi on top. And that right there, guys, pi over 9 radians is what our 20 degree would convert to. It feels a little funky. Never multiply by 3.14. Leave pi in your answer. When someone asks for a radian measure, pi will be in your answer. Also, do not divide 1 over 9. We don't want decimals. Radian measure is very fractional. Now let's go the other way. I'm going to convert pi over 4 to degrees and find out how many revolutions this is. Well, remember, pi, if I would go this far, that is pi. So this is like I want 1/4 of pi. You could think of that as 1/4 times pi. I want 1/4 of that. For me, I can actually visualize that 1/4 of pi. Okay, cut that into fourths. This is the angle I'm looking for, and I want to convert that to degrees. Now maybe you could do that even with just dividing up your circle here. You know you have 4 slices there and 180. Well, 180 divided by 4 would be 45 degrees. Okay, but let's try this conversion method that I mentioned before. I know pi is 180 degrees. So I have some amount of degrees over 180 equals pi over 4 over pi. Okay, so this looks a little weird, but if I took pi times x, I'd have pi times x, and x is what I'm solving for, equals 180 times pi over 4. So 180 times pi over 4. Notice how I wrote that fraction like this. This is like 180 over 1, so we can reduce that. We never want to decimalize, so let's work with this here. I've got pi times x equals, let's multiply, 180 times pi is 180 pi, and 1 times 4 is 4. Well, 180 divided by 4 actually reduces. Okay, this one will actually come. Sometimes you'll be left with a fraction that doesn't reduce. But 180 divided by 4 leaves you with 45. Okay, so this reduces to 45 pi equals pi x. You have a pi on both sides, so kind of weird to divide by pi, but pi is just a number, like 3.14, those would reduce. And there we're left with it, x equals 45 degrees. This is my conversion from radians to degrees. That fraction is a little scary when you have a fraction over a fraction, but that's how we'd handle it. Now for me, I'm better if I know the degrees to convert to revolutions. So a full circle would be 1 full revolution. Now that I know 45 degrees is my wedge here, how many 45s would fit in a full circle? Well, 8 of them, right? We could think of it as 360 divided by 45. That'd give me 8. So since I only went 45 degrees, my number of revolutions would be 1/8 of a revolution. Pictures can help. I know this conversion's a little crazy and the multiplying with the pi, but the more practice you get, the better. You could always use, instead of pi equals 180, you could always use 2 pi equals 360, but I just find those are bigger numbers, so I'm just going to stick with the pi equals 180 to convert. Again, it is totally fine if you can visualize this over here, that you have 1/4 of pi, and that would be cutting 180 into 4 parts, and there's your 45. That matches.